Welcome back.
What up? Let me just do the titles and stuff. Alright, where are we at right now? Let's do this. Let's see. Okay, where am I at? Okay, so I have the meteors. The next feature I need to do is to just I need to actually this music's kind of loud. All right. What is this? Okay. So now what I need to happen is I need these meteors to start randomly spawning. Let's see, I haven't looked at this code in a bit. Should I? Yeah, that should be good. So I should probably just initialize some sort of like global timer that has some sort of like a meteor, something like meteor interval equals like 30 something. And then essentially we just do let's see. So instead of doing this right here, what we're going to do is we're just going to move this, and on update, we're going to update the meteors. Update meteor. Hold on, this is really cooking real fast. Hold on. What were you cooking? Whoa. Except for star interval, I want to do what is initialize star interval for? Oh, it's for how when they blink. Okay. Instead of initialize star, I want a different one for meteor. Like that, except I want you to be like maybe like 5 to 21 or something. For random 128. Wow. Wow, I think this knows exactly. So the X needs to be at 120 at the edge of the screen. And this needs to be random to 120. And then from here we do meteor interval minus equals 1. Oh. Okay, yeah, we don't want that. And then I'll set the meteor interval to like 30. Alright, let's see how this works. Runtime error. That's line 106. Update meteor. Attempt to index local M and nil value. That's weird. And update line 39. What? Why doesn't that work? Well, that's not very useful. Oh, there's 2 update meteors. Whoops. Let's rename this to spawn meteor. How about that? Oh, and we're not calling this anymore. That is way too fast. But that is exactly what I want. So maybe like 15. You can go all the way up to like 30. Okay, they're also way too fast. Let's do minus like 5 or something. Okay, that is still way too fast. New meteor. Oh, dx minus 2. So minus like 1. Yeah, that's a lot better. Oh, when they're despawning. What do you need to be like 150? Let's try that. Okay. That's good. Problem is I don't want them to be, well, on collision I guess I should do like an explosion, right? I should probably draw an explosion, but for now, let's just commit this part. This feels like this is not in the right place. It feels like I can combine this with update meteor, but spawn meteor is in the scope of the whole game, whereas update meteor is in the scope of each instantiated meteor at the local event. So that's kind of the main difference here. Anyway. Okay, now what we need to do is we need to make some sort of explosion if it hits either the player or the guy. So we can just do like 3 frames. How do you make an explosion? Okay, these are way too complicated. Oh, this is perfect. So it's just the star basically, but with the fire color palette, so something like this. And then you just get some orange around it. And then just really get the red. Well, I don't want it to be too square. Really get the red like boom. Explosion coming out of it. Yeah. And then now we can just fill in whatever we need to here, just like this. Oops. And maybe add a little orange here. And then make sure the red outline is going all the way out. Boom. And let's start with a small explosion too, so maybe something like this. So boom, 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 boom. No, this doesn't feel really explosion-y. So, and we have enough room. We can even put a smaller explosion. Just like this. Well, it's a little flat. Let's do like this. Like this. This. That's not like this. So, maybe this could be a little smaller actually. Maybe it's a little small. Or a little big, actually. Let's make you about this size. Paint outwards. The explosion. I think I even want to make this guy a little smaller too. So like this small. So something like that. Okay. And now let's commit this too. Sweet. Okay, well now that I have that done. Oops. What? 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 Okay, now the problem is that the map moves at the same interval, and that looks kind of weird. So let's actually do these, do this. Kamehamehas. Draw map. Okay. Twinkle X. Update the map. There we go. Map X should probably be like point like 1 or something. It's a little too slow. Maybe like point like 3. That looks weird because now the stars behind are slower. So I guess it should be like 1. Okay. Great. Okay. Now I'm thinking, now I need to start working with flags. So let's try and figure out how do flags work. Pico 8 flags. I forget. Okay. What is happening right now? Go 8 map collision. Okay. Okay.
Hey, here is a really simple tutorial on how to code collision for Pico 8. This is something that I've struggled with quite a bit since starting Pico, and I finally kind of came up with more of a simple way to do it. And full disclosure, this is heavily based, just about completely stolen from this guy right here, Scathe from the Pico 8 forum. He writes a simple collision function. I've downloaded this and used this quite a bit, and so this tutorial is based on this code. A lot of it is completely the same. Some of it I've changed to be a little bit more beginner friendly, but it's very, very simple and a really great way to do it. So big props to this guy, play his cartridge, and it's just a sprite that has really nice collision all around. And it's just,
very nice.
So I really appreciate it when people make simple, easy things. So you can download this project from that forum. Again, it's just called Simple Collision Function on the Pico 8 forum, and he kind of explains it. Very, very nice. Full credit to this guy. So I want to just kind of explain how this works. This works for any kind of game. And man, it's just a very, very easy way to get collision going. So there's no built-in collision function for Pico 8. You have to write your own. And here's kind of the big idea of how it works. Here's my main game loop. This is just init, update, and draw. And I've broken out my player controls into an init function, a update function, and a draw function for my player. I also have clear screen and draw map here. In the second tab, I have all of my player stuff, which is just initiates the player. This just makes a player table with an X and a Y. And in the update function, we have a function called move, and we're passing the player into the move. And then we draw the sprite here in dplayer. So this is all pretty simple stuff that I've gone over in my other videos. One thing to point out is that we're passing this player object as an argument into the move function. Okay. So now here's where the fancy stuff happens. This is all the collision stuff. We're starting out with a function, and it's called move. And inside of this function, we're going to call whatever we pass to it O. Okay, this is just lowercase o, and here we are passing the player into it. So whatever we tell to move, we'll run through this function and push that object into everywhere where it says O here. So we're gonna move stuff. Basically how this works is, before we do any movement of the player for each frame, we're gonna take a little snapshot of where the player is right now. And we're gonna store those as a local variable inside of this function. LX and LY stands for last X position and last Y position. So we're just saving those out so that we can use them later. And then we're gonna try and move the player. And this is just normal movement code. These if statements are kind of shorthand. So if whatever's in the parentheses, then the stuff that's after it, okay? Just a shorter way of writing an if-then statement. So if button up,
man, why is he using the Pico 8 editor?
62, right? And same thing for down, left, and right. Pretty standard. But here's where the tricky part comes in. If it collides, if the player runs into a certain tile that's set to collide, we want to move it back to that original position, this local LX and LY. So every frame, if we have one of these buttons down, we're going to go ahead and move the player over. But if where the player is on top of a tile that it should be able to walk through, it's just going to move it back to where it was. So it quickly moves it there and then moves it back before it even draws the frame. There are a few other ways probably to do collision, but this is a really nice clean way to do it actually. If it collides, we're going to move it back. Now we're checking that with this collide function. And this is the same thing. We're just passing that same object, which in our case is the player, into this collide function. If it is true, then we move the player back. If it's false, we don't do anything, okay? So let's go look at the collide function. This collide function has a few things that are a little intimidating, but it's really, really simple. Basically, we're making a bunch of local variables here at the start, which just exist inside of this collide function. What we're doing is we're calling one x1, one y1, x2, and y2. And what we're doing here is we're grabbing the coordinates of where our player is based on the bounds of our player, the left, right, up, and down sides of the player, the edges. So this first one is our left edge. This last one is our right edge. This is our top edge and our bottom edge. And what we're doing is we're dividing it by 8 because what we're trying to get is not just the position in pixels of the player on our map, but we're actually trying to get the number of tiles. So we're trying to get these values down here. So if the player's over here, they're going to be at tile 6 on the X and tile 3 on the Y. So at tile 6, 3, that's right here. So these tiles are at tile 2, 6, 3, 6, 4, 6, and so on. We're just trying to find where the player is on the map. So this grabs our edges and stores them as variables. Now we're going to take those variables and we're going to test and see if any of these edges are touching a tile on the map that has a certain flag. So this map right here has a bunch of different tiles, and these little wall tiles here, those each have a flag, this 0 flag right here, this first flag. And that for our purposes is going to mean that, hey, the player's going to collide with this. He shouldn't be able to walk through this. So every frame, it's going to check where our player is and if he's touching one of these tiles that has that 0 flag. That's what's happening here. mget is get the sprite that is at this coordinate, x1, y1, and fget is get the flag. This is testing if it's flag 0, and if it is flag 0, then A is true. If it's not flag 0, A is going to be false. And same thing for A, B, C, and D. This is testing all of the different corners of our sprite, and we're just checking, okay, is this corner over anything that's going to collide? Yes or no? Is this one over anything that's going to collide? Yes or no? Is this one over anything that's going to collide? Yes or no? How about this one? Yes or no? And if any of these are true, then our player is over something that he shouldn't be over. So that's what we're asking here. If A, B, C, or D are true, that's what this means, then return true, else return false. Return is a command that basically sets this collide. Whenever we test for collision, it's going to return true or false. So we can return collide as true if any of these A, B, C, or D's are true. And if they're all false, then we're going to return false. So this is a big way to test if the player is colliding with anything they should be colliding with. If they are, then we set this here and we say, okay, if the player is colliding, if the player is where it shouldn't be, then we're going to move that player back to where he last was. So this all happens within one frame. So this collision, when we say move, which we're calling every frame, anytime we update, we're just going to call move. It's going to say, okay, where's the player now? All right, we're going to remember where the player is, and we're going to test what button you're pushing. So if you're pushing right, we're going to go ahead and move the player right. And now let's see if this new place where the player is, one pixel to the right, is he colliding with anything? Let's go ahead and test if he's colliding. All right, let's get the edges of the player, and we're going to test if any of the corners or edges of the player are touching anything they shouldn't touch right now in the new position. And if everything's good, we're going to return false. But if they are touching anything that they shouldn't be touching, we're going to return true. That means that we are colliding. If we are colliding, move it back to where it was. If we're not colliding, then go ahead and keep this new position that we just told you to. And what ends up happening when we run the game is that we can move wherever we want unless we run into something. And then anytime we run into something, it's checking that new position that would happen if there wasn't something in the way and saying, ooh, we can't move there, so just move back to where you were. And the effect is that we just stop when we touch something. So this is great to combine with gravity or with really anything we want to do. You can have kind of a 4-way movement, top-down sort of game. You can use this with a platformer, whatever you want. It just doesn't let the player go through things that he shouldn't go through. And you can make this more complicated with all kinds of different flags and different state machines and all that stuff. But that's basically how it works. Inside of our move function, going ahead and moving it, and then checking if that new position is colliding. And if it's not, we leave it alone. If it is, we move it back. I think that's a really nice way to do that. Again, full credit goes to this genius here on the...
I think I also want a blue explosion. So here, let's just do like the red. And let's add some like blue sparks coming off. I don't want it to look too rectangular. So this is just what happens if either you get hit or the shield gets hit. And this is again too flat. That's awesome. Oh, so this is gonna be the animation for it when it explodes, like on the laser contact. This is gonna be if it hits me or if it hits the ship, both which are bad things. Okay, so things that need collision: the meteor, the player, the shield, and the laser. This I just don't need anymore. Alright, let's actually move you here. Just like that. Okay, so what's going on here, right? I need a meteor is going to be flag. Going to be this. Nope. And the Kamehameha flag is going to be this. Not the fire. Shield. Oh, I need to rename this guy. Just can't do it anymore. Oh, wait, that actually worked. Oh, sweet. Okay, great. That was completely wrong. Okay. Now, so now that I have the player and the meteor explosions, all I need to do is actually code up the collisions.
In an earlier video, I've looked at collisions between two objects, or more specifically between two squares or two bounding boxes on objects. And it's a really useful way of finding out collisions, especially when two objects are moving, or they're binding sprites or something like that. But against the background, that's not always the most sensible way to do things, because actually the background shape is quite irregular, and also it's got a lot of tiles on this background. You can see here my background is all over the place. And so to have some sort of specific function that knows where my background is and is able to calculate a collision is going to be really, really tricky. I could ask if the pixel underneath my character is a certain color and then make a decision based on that, but that also is a little bit restricting. My background would have to be the same sort of color, and it's just not going to work very well. So instead I'm going to rely on two really important code words called fget and mget. And I'm going to rely on the idea that although my object is located at a particular XY location on the screen, it also occupies a location based on the grid occupied by the background. And if you haven't watched it already, there's an earlier video that looks at calculating the grid position of an object based on its X and Y location. And so if you want a little bit of an idea of why some of the code in this video is the way it is, have a look at that earlier video just so you can get a good idea about what's going on, because I'm going to use the function floor, and I'm just going to use it without talking about it in a great deal. So if you want to know about that one, use the earlier video. So let me just reboot PK8 here, and we will look at beginnings of a platformer based on two really, really useful functions. So let's run it. First thing we're going to need are some sprites. So I'm going to create a background, make it basically grey with a nice edge to it like this. Okay, so those are my background tiles, and they're going to tile all over the game screen. I might actually just add a little bit of shadow on this side as well. Okay, so there's a background screen, and I'm going to have a little character
Shadow.
move around the screen. Okay, my character is going to look like this. Okay, there's my character. Okay, so I've got a background and a character. And I'm going to draw a map on here. Now remember with the map, if you press the spacebar, you can see the edges of the map there. I'm in the top corner of it. So we need to start drawing the top corner. To keep things simple, you can draw wherever you want, but if you draw elsewhere, you're going to have to think more, and who wants to think too much on this. Don't forget also, if you scroll vertically like this, these down here represent the bottom of the screen. So I'm going to put in a bottom level here, like that, of my grid. Okay, and then I'm going to build it into
Oh wow, that does look nice.
Up here, I'm going to put
What the heck? That looks really nice.
sort of thing, and then maybe up here, a couple more.
What the heck?
Background. Okay, so there is my background. Remembering at the
Wow,
moment,
that looks amazing.
Now, this part here is at 0, 0. You can see
I wasn't
down
convinced
here.
just seeing it, but now I see the vision.
So let's go to some code and get some of this on the screen. So function draw. I'm going to clear the screen. Before I do anything else, I'm going to put an ending. I'm going to clear the screen. I'm going to draw the map. 0, 0, 0, 0, 16, 16. So hopefully you all know what's going on with that. And I'm also going to draw my sprite. And I'm going to draw it to the XY location. Then sprite 2. Okay. I can hash that to XY. Close brackets. That's what I want. And then just make sure everything's running okay. I'm just going to have the X equals 63 and the Y equals 63. Okay, so if I press escape and type run, there's my object sitting there. Okay? And my background. Now, let's have our next bit, which is going to be our function update. Okay, we'll put an end in, and I'm going to do the usual sort of movement. So I'm going to say if btn naught, then x minus equals 1, end. I'm going to copy that, and I'm just going to paste these in. Okay, so we've got button 1, button 2, button 3. This one is incrementing x, this one is making y move, this one is also making y move, but in a specific direction. Now this isn't very good platform. I really want to implement some gravity to make things jump around, so it always drops to the bottom of the screen. I'm not going to do that straight away, but you can see that my object can move anywhere on the screen, and in fact, through my background. So there's a few things I'm going to need to do here to make sure that this works. The first is I want to make sure I know where the object is in terms of the grid. Okay, so I need to ask grid x, and these are just for demonstration, by the way, the grid x and grid y. You'll see in a second when I start to actually program this that these aren't absolutely crucial, but it just helps to keep us in a frame of mind where we know what's going on. So grid x is equal to the floor of x over 8, okay, and grid y is equal to the floor of y over 8.
Nani?
Grid x, comma, grid y. And I'll put it up, say 5, 5 in white. Alright, so if I, that's not going to work, I've just realised I've missed some dots. If I run that, there's my grid location. Okay, so if I'm right up here, I'm in square 0, 0, and if I scroll down towards the bottom of the screen, I should end up at square 16.
Oh,
That's square 15, which is the 16th square across. Okay, that's just useful for us to keep track of what's actually going on. As I say, it's going to be a little bit more complicated than that. Really, what I'm going to need is a function. Let's just have a little look at what this function is going to be doing. So I'm just going to have a simple grid system here. Okay, and I'm only going to look at 4 squares. And in this square here, there's going to be some okay, so some sort of background I don't want to hit. Okay, the other squares are fine to move through. So what's going to happen? Well, I'm going to take, again, the old bounding box idea. Let's say my object is just here, okay? And I happen to know that this location here is the x, y location of my object. And my object will have, as always, a width and a height. What I want to do is I want to check every pixel across here and every pixel down there to see whether any of these collide with any object. Because if you imagine, if I'm moving in this direction, the x and the y are here. There's no point in just checking x and y, I need to check x and y plus the width. Because if the width touches there, I know it's not going to work. Okay? So this is what I'm going to do. I'm going to check the location. I can make it quick by checking the 4 corners, which is what I'm going to do. So I'm going to check the 4 corners. Because in the end, that's going to be a quick energy saving way of doing this. And I'm going to check, is this corner in touch with something? Is this one? Is this one? And is this one? So let's imagine this object here moving over to the left by a speed of, let's say, okay, so it's going to, in theory, end up here. So that is speed. I'm going to check this corner, this corner, this corner, and that corner. Okay? And that's going to tell me if there's a collision. Now what's going to happen is it's going to say, yes, yes, there is a collision, and it's going to prevent me from moving into the box. And I'm going to do that in all different directions. And by doing that, I can find out whether there's a collision with the background. So I have to basically know the grid reference. So this one here would be, if I look at just this left button here, although there's an x and a y value, the grid reference, I count these, is 0. Okay? And when I move to here, the grid reference is 0, 0. And my map on screen is drawn from the map section of Pico 8. And the map section of Pico 8 will have grid section 0, 0 coloured in with a tile, and grid section 1, 0 empty. And so when I move into grid section 0, 0, it will say there's a tile there. So there's a few bits and pieces I have to do to get that to work. So if I go back now to my code, what I can look at in here is this. These are flags, and I can set any of these flags that I like. So I'm just going to set this first flag here. Okay, so flag 0 is going to be set as a 1, or on, true, sorry, okay? That then means that all of these tiles here, which are all belonging to tile 1, will have a flag set to 1. So we're going to use a really useful function called mget and fget. I'm going to introduce two new variables. Map tile, which equals 0 to start with, and flag tile, which equals 0. And these are going to give me the values for the map and the flag at a particular location. So map tile is just equal to mget, and I just give it an x and a y location. And the x and the y is grid x, grid y. And down here I could print map tile at a location of, say, 5 across and 11 down. Okay? So if I run that, you can see I'm on tile 0, tile 0. If I come up here, tile 1, tile 1. So it knows what the tile is underneath. Okay? So you can see tile 0, tile 1, tile 1, tile 1, tile 0. Remembering, of course, it's basing everything on that top left corner. If I go into my sprite and I just make sure that this one here is in bright yellow. That's what's triggering it. So as I go across, you can see tile 1. So you can see this is going to start to get useful. Let's now get the flag. Okay, so flag tile equals fget, and you have to just give it the map tile. So this is now going to give me the map. Oh, sorry, I'm going to need to print that as well, aren't I? So let's just grab this one, Control C, and underneath flag tile, and I will put that another 7 down, so it's 17. So if I come this way now, you can see whenever I'm over a particular tile, you have that. Just to give you an idea of things, let's imagine I had some sort of lovely background idea that maybe looked a little bit like this, for whatever reason, and that square sometimes gets pasted around. Okay, so I'm just doing this, and it's just a sort of decorative style of thing, and isn't necessarily anything to do with the game. Okay, maybe it's just some sort of decoration like that. If I run this, you can see I'm over tile 3, over tile 0, it's fine. They've all got a flag value of 0, but when I move over one of these, the flag is 1. So that's going to be really, really useful. And in fact, you can shorten this. You see where I'd say map tile equals mget grid x grid y, and flag tile equals fget map tile. Well, what I can do, I can get rid of the map tile variable, so I'm not going to print that anymore. So this one's going to get printed up a bit. And instead, I can just say that the flag tile equals fget of mget grid x grid y. Okay, so I'll just get rid of this bit code here as well. So now I'm just getting directly backwards. If I run it now, you can see nothing, 1, nothing, 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 1, and so on like that. Okay, and so sometimes you hear people talking about fget mget, and that's what they're talking about. You take the flag of the map of the grid reference. So that's how fget and mget work. But they're not really stopping us from moving at the moment. To stop us from moving, we're going to need to really wrap it all in a function. So I'm just going to write a function called hit, and it's going to take a couple of different things. It's going to take the x and the y location of the object, and it's going to take the width and the height of the object, and that's all I need to know. It's functions, we want to close it, and the first thing we'll do is just set a variable called collide, and it's going to be false. And then I have to ask a couple of questions, and the questions are in the x and the y direction. I need to know, is there a collision in the x, or is there a collision in the y? So I'm going to loop through the box. Now if you remember from just a little bit earlier, here's our object, this is the xy location, and I wanted to check there, there, and there. So how am I going to do it? Well, the easiest way to do it is to go, okay then, if I do a for loop, let's go x to x plus width, okay? But I don't want to move through every single tile, so I can just move by width, okay? So if you remember the for loop, you can set how much you want it to move each time, and I want it to move by the value of width. So it's only going to give me two values, x or x plus width. So that's what I'm going to do now. So in here, I'm just going to say for x equals, sorry, not correct, for I equals x, comma, x plus width, comma, width 2, and remember to close it, end. Well, I'm going to ask the question, if fget, mget, so in other words, if the location at I over 8, alright, comma, y over 8. So in other words, I'm checking the width.
Oh, hell nah. You're banned. That's a new one. I haven't seen this one before. November 5th, 2024. What the hell? Banned. Terrorism. Oh, dude, what is happening?
Or, if you've got to be careful here, fget, mget. We want to do the same again, I over 8, but we're looking for the bottom, okay, down here. So down at the bottom, down at this point on my picture. So we want y plus h, which needs to be in brackets, so in other words we're checking. So I move my mouse. Y over h, so y plus h over 8 is greater than 0. There, okay? So what I've done is I've said, if the flag in the top left corner, or the top right corner is greater than 0, or the flag in the bottom left corner, or the bottom right corner is greater than 0, then, well then what? Well then we fix something, because we've got that flag. So collide equals true, and we can close that end, okay? So now we can go back to our movement over here. I've still got these values for grid x, grid y, flag tile, just to show you what's going on, and we'll leave those in for the time being, but they're not crucial to the actual code itself. So the next question to us is this. We want to move our object. Are we actually going to be able to move our object? Now what's happened here is in each instance, I've tried to move the object by a certain amount, okay? But there's a better way to look at this. I'm going to separate out the x and the y's, and I'm going to have a new value here, which is just going to be dx, which is 0, and dy, which is 0. And if I press the button left, I'm telling dx to equal -1. In other words, I want it to move by -1. I'm not yet moving it. And I want here dx to equal 1. And in this one here, I want dy to equal -1, and I want dx to equal, not dx, dy to equal +1. So this allows me effectively to preset how I want the move to happen. I'm saying here, if I press button 0, I want it to move to the left. And if I press button 3, I want it to move down the screen. In other words, I'm saying dy to 1. Because then what I can do is I can ask a simple question.
What?
There is a hit in x plus dx, comma y, and then I have to give it the width and height of the box. Remember the hit function down here, x, y, width, height. So my box is going to be a 7 by 7. Okay, the reason it's 7 by 7 is down here I want to add a bit to it, but I want to stay within the box. Okay, we can fiddle around and have a look at these things. So if there is a hit, then we're not going to do anything. We're just going to set dx to equal 0. End. And then we need to ask the same in the other direction. So we need to say, okay, then, this is what about in the y direction? So in this instance, we leave x as is, and we take y plus dy. Okay, and that gives us this one down here. And now we can say x plus equals dx.
Oh, I mean, I guess I don't really need
So
that though.
oh,
Well, I wanted to collide to the shield.
Okay, we come down to our function. We have not returned the value. We've done all of that work, and we haven't bothered actually telling anyone what on earth's going on. Let's return. I can spell it correctly. return collide. If we don't return the value of collide, then the function hit just returns false all the time, and it's just returns false all the time, which is pointless. We do actually want, having done all these calculations, to return a value of true. So if hit set speed 0, if hit do the same. So let's now see. If we run our code, you can see we just bash into things. So it's moving, bash, like that. And you can see there you've got a nice bit of collision detection. It runs quite nicely. Now, there's a couple of things to realise with this fget mget. The first is if your speed is higher, this very simple collision detection here won't work. You're going to need to loop through every single position that it's going to be in and check your collision from there. And that's quite important. There's an earlier video, if you look at the collision detection using the hitbox ideas, then that talks about how to loop through. So I kept the speed of 1 because it's very simple. The other thing to realise is this. If the location of your map tile moves here, then actually it matters a lot. Let me show you what I mean. Here I'm going to just come across a bit like this, okay? And I'm going to draw this all the way out to here. Alright, so here is a new background, okay? And my new background looks a bit like this. I'll put some purple bits here as well. And I can draw that background, as you know, by just changing my positions here. So I want to draw instead the map that's at 16 naught. So if I run that, there's my new map at 16 naught. But if I move around, you can see I'm banging into things that exist elsewhere, okay? It's not following what I expect. Here we go, come down, and start sideways, okay? And what it's doing, of course, is it's colliding with the original map. So here, if I move, or for example, I can't when I start, because my start again, if I press run, I can't move down. If I change this back to 16 and run it, I can't move down. And it's because the location isn't relative to the screen. It's not what I can see on the screen. It's relative to the actual map over here. Okay, so this is what actually matters. This map.
Bro, what?
I need some sort of value here. So I would call it something like map x, which equals 16, and map y, which equals 0. Okay, and then down here I would draw my map at map x, map y. Okay, so that's drawn my map x and map y. And so my collision up here is very important. It's not just x and dx. So down in my fget mget function, I'm going to need to shift these plus map x plus map y. Okay, and down here plus map x, and this one is also plus map y.
I see.
With my original. Now that's very poor programming, because I have assumed that this value is global, and I haven't passed it to the hit function. So maybe what I would do is actually here, I would pass it to two variables. Map
Okay, I think I'm starting to get it.
Incorporate those into there so that the function is self-contained. But I just wanted to get across the idea to you that it's not the screen that matters, it's not what's on the screen, it's what's on the map. And if you are drawing a different map, you have to remember to offset the mget collision. Okay, so that's how to use mget and fget together to create collisions with background. There's some complications involving the shifting of the map and varying different speeds, but the basic idea is the same. You can use these flags to work out collisions, and it's a really nice way of doing collisions.
Okay. Let's try hitbox. What is this? This feels like something I actually want.
A couple of videos ago, we looked at starting off how to work out collisions. And we wrote a little function called boxhit, which could tell you whether two boxes, if you like, had overlapped. So what I'm going to do in this video is use that function, the boxhit function we did earlier. And I'm going to use it to implement some collisions, because you can see here, I've got an orange dot that's rolling around the screen, and a red box. And I would really, because that's the crucial aspect of this game, I would really like the orange dot to crash into the red box, but at the moment you can see it just passes through. So we ask ourselves, well, why is it just passing through? And if we look at our code, we've got some very basic code here. We've got an x and a y variable, and some speed, and an enemy x and an enemy y. I've just given it the values ex and ey. And you can see I've got some very basic code here in the update function to allow me to move the object down the screen. So when I press button 0, the x value is decreased by speed. When I press button 1, it's increased, and so the object moves left and right. Equally for button 2 and 3, the object moves up and down. And then down here in draw, I clear the screen, I draw sprite 1, which is just the orange circle, with the screen in positions x and y, declared here, and I alter here. And I draw sprite 2, which is our box, at enemy x, enemy y, it's a 2x2 sprite. Now I could have used circfill and rectfill here, but I'm just going to use sprites because it makes things a little bit more relevant to the
Okay.
thing you might be actually doing in the game. So you can see quite quickly, I have no collision detection. If I press a button, the sprite moves, and that's that. Now I have pasted in the boxhit function that we wrote earlier. So this one, if you remember, it takes 8 values. The boxhit function takes the x and the y of one of the objects and its width and height, and the x and y of another object and its width and height, and then it returns either a true if there's been a collision, or a false if there hasn't been. Okay, so it's false up here, you can see, and it returns true if the hit has taken place, and we worked our way through that.
Check if the X will speed.
Previous video. So I do know, therefore, that there is a command that is going to tell me if these two objects I are.
fget, mget, go. Let's see. I saw it on the map. Okay. Can use these flags for any purpose. FGET is called without a flag index. It returns a number that represents all the flags. It's the bit field where flag 0 is the least significant bit. Flag 0 leftmost has a value of 1. Right. Okay, so let's just make these guys this. We're not going to make that the hitbox. So the meteor flag is actually not here, it is here. The Kamehameha flag. Player flag. Should be this one, and this one. This. So the player flag should just be this guy, right? Fourth one. No. Yeah, that's fine. This is the laser flag, which is number 2. Hell yeah. Shield flag should be number 3. Okay. Let's just do this just for consistency's sake. Okay. Okay, dokie. is to say, okay, look, we have all the things. Probably need to update the objects. So as say, like, okay, if you are the shield and you collide with the let's just make like a game over. Game over is equal to false. And then you just say, okay, let's just update. Yeah, if wow, that's fucking perfect. Okay. Let's see. Oh, this is why you don't rename every instance. Okay. So let's just do the first part, which is we need to make sure the player doesn't collide with the map. So all we need to do.
So if there is, I would pass it to ask is this. We want to move our object. Are we actually going to be able to move our object? Now what's happened here is in each instance, I've tried to move the object by a certain amount, okay? Oh, no, you can't see because we've made a mistake somewhere. Let's have a look around. That looks okay. We can actually want, having done all this calculation, to return a value of true. So, equals, called mget and fget, tile naught. So it's just a variable called collide and it's going to be false. And then I have to ask a couple of questions. And the questions are in the x and the y direction. I need to know, is there a collision in the x or is there a collision in the y? So I'm going to loop through the box. Now if you remember from just a little bit earlier, here's our object, this is the xy location, and I wanted to check there, and there. So how am I going to do it? Well, the easiest way to do it is to go, okay then, if I do a for loop, let's go x to x plus width, okay? But I don't want to move through every single tile, so I can just move by width, okay? So if you remember the for loop, you can set how much you want it to move each time, and I want it to move by the value of width. So it's only going to give me two values, x or x plus width. So that's what I'm going to do now. So in here, I'm just going to say for x equals, sorry, not for x, for I equals x comma x plus width comma width 2, and remember to close it, end. So what am I actually going to do? Well, I'm going to ask the question, if fget, mget, so in other words, if the location at I over 8, alright, comma, y over 8. So in other words, I'm checking for where it is and where it is with the width over 8, okay? So if that flag is greater than 0, or, because we've got to be careful here, fget, mget, we want to do the same again, I over 8, but we're looking for the bottom, okay, down here. So down at the bottom, down at this point on my picture. So we want y plus h, which needs to be in brackets, so in other words, we're checking, sorry, everyone else, y over h, and y plus h over 8 is greater than 0.
What?
Okay, so what I've done is I've said, if the flag in the top left corner, or the top right corner, is greater than 0, or the flag in the bottom left corner, or the bottom right corner, is greater than 0, then, well then what? Well then, we've hit something, because we've got that flag, so collide equals true, and we can close that end, okay? So now we can go back to our movement over here. I've still got these values for grid x with y flag time, just to show you what's going on, and we can close that end, okay? So now then what? Well then, we've hit something, because we've got that flag, so collide equals true, and we can close that end, okay?
Oh, okay. I think I can steal this and then make this more generalized. Yeah. Let's do function object collision. Is object colliding? What the heck? That is not going to do it. No, that's not what we want. Objects. With map. Whether it's the player or the meteors. X. The width and height. None of the objects have any width or height. Is there any width or height?
I'm not going to print that anymore. So this one's going to get printed up a bit. And
It's
instead,
width
we'll
and
just say
height.
flag tile equals fget equals 0 to start with. Have a simple grid system. See that. Yeah. Okay. So there's a few bits and pieces. Yeah. Is this. These are flags. Yeah. Is this. These are flags. And I can set any of these two new variables. Map tile, which equals 0 to start with, and flag tile, which equals 0. And these are going to give me the
What
values
is
of the map and the
X?
flag at a
Or what is
particular
W and
location.
H?
So map down. Okay. So if I run that, you can see left up corner. Okay. So flag tile equals fget, and you have to just give it. You have that. Just okay. Maybe it's just equals to a function called hit, and it's going to take a couple of different things. It's going to take the x and the y location of the object, and it's going to take the width and the height of the object, and that's all I need to know. It's a function, so we want to close it, and the first thing we'll do is just set a variable called collide, and it's going to be false. And then I have to ask a couple of questions. And the questions are in the x and the y direction. I need to know, is there a collision in the x or is there a collision in the y? So I'm going to loop through the box. Now if you remember from just a little bit earlier, here's our object, this is the xy location, and I wanted to check there, there, and there. So how am I going to do it? Well, the easiest way to do it is to go, okay then, if I do a for loop, let's go, so it's only if and get corner. But there's a better way to look at this. And then well, let's return, if I can spell it correctly, return collide. If we don't return plus dy, okay.
Okay. Okay. Oh, this looks correct.
Y over 8. So in other words, I'm checking for where it is and where it is with the width over 8. Okay. So if that flag is greater than 0, or, because we've got to be careful here, fget, mget, we want to do the same again, I over 8, but we're looking for the bottom, okay, down here. So down at the bottom, down at this point on my picture. So we want y plus h, which needs to be in brackets, so in other words, we're checking. Sorry, move my mouse now. Y over h, and y plus h over 8 is greater than 0. There. Okay. So what I've done is I said, if the flag in the top left corner or the top right corner is greater than 0, or the flag in the bottom left corner or the bottom right corner is greater than 0, then, well then what? Well then we've hit something, because we've got that flag. So collide equals true. So now we can go back to our movement over here. I've still got these values for grid X, grid Y, flag time, just to show you what's going on, and we'll leave those in for the time being, but they're not crucial to the actual code itself. So the next question to ask is this. We want to move our object. Are we actually going to be able to move our object? Now what's happened here is in each instance, I've tried to move the object by a certain amount, okay? But there's a better way to look at this. I'm going to separate out the x and the y's, and I'm going to have a new value here, which is just going to be dx, which is 0, and dy, which is 0. And if I press the button left, I'm saying dx to equal.
Alright, is this jump gonna work? Nope.
So we had more. Then. But what? We need to fix. Cool.
Okay. I see what's happening here. So he just grabs the points and then just slaps them on. What is FGAT again? Oh, it's right here. It's the value of the flag of the sprite. Oh, I think this is a way easier way to do this, actually. Let me just try this instead, actually. So we'll do what is object colliding with? Clear no. Huh. If O.cm doesn't make any sense. I kind of see what they are doing here, but it's not really, I don't really need that for me, for my purposes. I think I just take local, let me just say if the player, let's just make my life easier. If, well, no, I do want to generalize this to the meteors. Colliding with shield. With the shield, and then I'm just like, okay. Over 8. Hold on. 7. Guess I just don't need this. Just make this, makes this call up here. Incorrect. I feel like there's a better way to do this, but whatever. Okay. Kind of like this. Oh, I guess I do need the width and the height. And this should be the shield, which the shield sprite is... Oh. I forgot to save. Shield sprite is 3. The meteor flag should be 1. Kamehameha is 2, shield is 3, and player is 4. Okay. And 16. Problem with that, though, is that the meteors are smaller. Well, I guess if we're just checking the collisions with the shields, it doesn't really matter, right? width, height. Alright, please, dear God, work. Does not work. Why do you not work? Is this thing even being called? Please. Why? But why though? But why is this nothing called? Call this thing. Why don't you call? Nothing's being printed. Wait, what? What? Oh, this needs to be put in the draw. Okay. So I know that it's the it's game over. The game over's not working. But why? Oh, because these need to be 3. Is that why? Nope. Why is it divided by 8? I don't understand the divides by 8. Alright, let's ask Jippity. Let's see if Jippity knows. Okay. Assuming I'm not being gaslit here. Oh. Alright, let's just do the ye old drop the whole thing in Jippity and see if it figures it out. Cause I'm starting to get a little annoyed and I'm gonna have to leave soon. The El Clasico. Why is the collision not working? This is so bad. Hail Mary. Yeah, the collision. Okay. Wait, this is actually what the other guy did. Let me try this. Hold up. Yo, they might be cooking. Hold. Oh wait, this works, right? This does not work. This doesn't freaking work. Of course not. But why? Okay. GPT is really fucking bad at Pico 8, but let me see if it can cook like a system that might actually work well. Yeah, something like this. Now this is interesting. Wait, bounce back? I didn't even think of that, but that actually might be a better mechanic than to just die. Like, what if it bounces you back into the laser? Like, that would be kind of funny. Wait, something like this is exactly what I want. This isn't using the flags at all, though. This doesn't use the flags. This is so weird. No, it doesn't understand. It doesn't understand. I want something like this, but I need to do it using the flags. Alright, anyway. Yeah, this is not happening right now. Alright, well, I'm gonna end the stream right here. That was a solid stream. Farewell, everyone. Bye-bye.